So we want to talk a little bit about what these words mean. We're dealing with number problems, and to do that we really do need to have a good understanding of this stuff. So the first thing that we're going to do is just remember what integers are, and of course the set of integers. I'm just going to write the same type of thing down that we did when we were talking about sets of numbers. So -1, 0, 1, again to infinity. So these go all the way to infinity, both negative and positive. When we talk about the word consecutive, we just remember that it means successive, or one after the other. So consecutive integers are just like the ones I have listed. -1, 0, 1 are consecutive integers. Or you could do 1, 2, 3, 4, 5, 6, so on and so forth. Also go in the negative direction. So the idea of consecutive integers, 1, 2, 3, -3, -2, -1, any variation on the theme. And then we go to consecutive odd integers. So consecutive odd integers, the same idea, it's just now we're making sure that the numbers are actually odd. So things like 3, 5, 7, or again, you can do it with the negatives. Consecutive integers, the same idea, 2, 4, 6. So hopefully you're getting the idea of consecutive, one after the other. Odd and even integers just means you're doing exactly what it says. You're only allowed to use the even integers, or you're only allowed to use the odd integers. We also need to think about how many. So, and most of the time it's going to be very obvious, particularly at this point in time. They're going to tell you 2 consecutive integers, for instance, or something like 3 consecutive odd integers. So it'll be very specific. Now when we use these ideas, we are going to use x as our first integer. What we have to remember is, if we're trying to solve something, 3 consecutive odd integers. So let's just say, all right, we know that the first one is x. So could we do x plus y plus z? And the answer is not yet. Certainly later on we might have the capability to do this when you get to college algebra. But at this point in time, we don't know how to do things. We certainly don't know how to solve equations with 3 variables. So when we start using these ideas, we have to get everything into one variable. So we name the first one x, and if it's a consecutive integer, think about this in terms of, let's say we had 3 and 4. So 3 is our x, say, and 4, how can we sort of quote-unquote name 4 based on 3? Well, 3 plus 1 is 4. So the same thing happens here. We just don't know what x is, but we do know the number after x is x plus 1. And if we had 3 consecutive integers, we would have the number x, again we have to go back to our original, and the number after this one would be x plus 2. So hopefully this is starting to make sense. In our example over here, that would be 5, because 3 plus 2 is 5. So hopefully you're getting the idea. Now here's a nice example of a type of problem that we could encounter, a nice basic type. So we say we've got 2 consecutive integers. Remember, we have to express them in one variable. We can't do x plus y is equal to 21. We don't know how to do that. So we know that we've got 2 consecutive integers. It's giving us information. And we know that they add to 21, and we want to know what the integers are. So the first thing we do is define or describe the variables. So our first variable, we know that we're going to put an x down for. This says 2 consecutive integers. So after that, we know would be x plus 1. So those are our 2 integers. So our equation is saying that when I add these two, it's equal to 21. So we have x plus 1, is equal to 21. And now we solve this just like we would solve any other equation. So We see that we are adding a polynomial, so we know we can just drop the parentheses, and then all we have to do is simplify each side. So we have 2x plus 1 is equal to 21. We get our variable alone, 2x is equal to 20, and lastly divide out that coefficient. So x is equal to 10. Then the next thing that we have to do is determine whether or not we answered the question. And the question was, what are the integers? So what we have here is one of the integers. So we have x is equal to 10. We know that the next one is x plus 1. So that's 10 plus 1, which is of course 11. So our second integer is 11. Now how do we test that? Well, we go back and we say, are they consecutive integers, 10, 11? Obviously they are. And do they add to 21? 10 plus 11 is 21. So we have got our answer. So let's do another little variation on the theme here. Here it says one number is 8 more than the first. So we know that our first number is x. It tells us that the second one or the next one is 8 more than that one. So x plus 8 is the next number. Then it tells us their sum is 88. So it's telling us to add these two. So we're doing x plus 8. And it says their sum, of course, is 88. And now, again, we do the same thing. We just simplify and solve. And it asks for the numbers, so we know that x is equal to 40. The next one is 40 plus 8, or 48. So our numbers are 40 and 48. Now this one says we've got 3 consecutive even integers and their sum is 48. So what are the numbers? So 3 consecutive even integers. Our first one, of course, is x. Now they're even integers. So let's go back to that idea that we had before. If I had 2 is my first even integers and 4 is my next one, 2, 4, 6. Well, how do I get my 4? Well, 2 plus 2. How do I get my 6? Remember, I'm going back to that original. 2 plus 4. So when I start looking at my even integers, I've got x plus 2, and x plus 4. So that's how I can express 3 even integers. It says their sum is 48, so I just add them. And then it says what are the numbers. So now at this point all I have to do again is simplify each side. So 3x, and I'm going to do this pretty quickly. 3x plus 6 is equal to 48. And then divide by 3. Now again, we go back and say, what are we trying to, or what question were we asked? And the question we were asked are, what are the numbers? So we have one of the numbers. We got x is equal to 14. So x is equal to 14, but the next number is 14 plus 2. And the next number is 14 plus 4. So our numbers are 14, 16, and 18. Now if you want to, you can go back and say, all right, I need to add these. These are 3 consecutive even numbers, so we know that that's okay. 14, 16, 18, all even and consecutive. If we add these, they should equal 48. So when we combine this side, let's see, 30 plus 18, oops, I'm supposed to say 48, not 40, sorry. That's a true statement, so that means that we do indeed have the right numbers. Again, a little bit of a variation on the theme. It says, what number added to its double is 51? Well, what number added to its double? Well, the number we're going to express as x. The double of x is 2x. Hopefully that makes sense. X doubled is 2x. And then it says what number added to its double, so we need to add these. So we're going to do x plus 2x is equal to 51. Then we just simplify and solve. So that's the number that we're talking about. So it says what number added to its double is 51. We've answered that question because 17, when we add 17 to its double, which is 34, we get 51. So we just checked it. We're correct. And let's just do one more of the consecutive integers. 3 consecutive integers, so we have x is our first number. These are consecutive integers, so again, just going to be x plus 1, x plus 2. They add to 9, so we say x plus 1 plus x plus 2 is equal to 9. And then we go ahead and we combine like terms. And then we solve like we would solve any other problem. Dividing out that coefficient. So x is equal to 2. So x is 2. The next one then is 2 plus 1, or 3. And the next one is 2 plus 2, or 4. Now when I add these together, there's 5. 5 plus 3 is 9. So we know that we're good. So the 3 consecutive numbers that add to 9 are 2, 3, and 4.